Today we'll be doing a GFG problem, flatten binary tree to linked list. Now a binary tree will be given and will be converted to a linked list. Okay, now if you are new to the channel, please do consider subscribing the channel and do check out more of the playlist that has been already uploaded and keep learning the things. Okay, now moving towards the problem statement of the flatten a binary tree to linked list. It's like a binary tree will be given and we have to perform like all of the tree in a single, like it we have to put all of the element in a single row, and it should be like representing a linked list type of thing. Okay, so what we will be doing is like first you can see like a first node will be given like a binary tree, and whatever the left part will be there, we'll just shifting it to the right part of it, like 1 2 it will come, then 4 sorry, then 3 and then 4. So we'll be just whatever the left part will be there, we'll just move it between the previous and the right part, so it will be linearly arranged in that way. Like whatever the right part is there, it will be arranged in the middle of 1 and 5. So 2 3 and 4 it will come in between 1 and 5. Here you can see like it has been arranged in that way itself. Like here also you can see like 1 and 3 is given to the right part, so 3 will be coming between the root and its right element, so in between it will come. Like here in the output you can see like 1 3 and 4, then 2 is in the left part and the right part is nothing, so it will be shifted to the right part itself. So 2 and then 5, so it's a bit easy thing. Now moving toward the problem statement. Now we'll be putting like a stack, you will be using like a stack element, and we'll be putting like 2 will be push, and then we'll be pushing that 4 and then 3. So when we are popping out, 3 will come first and will get attached, and then 4 will come and then it will be attached. So we are doing in that way. So we'll be using like a stack over here. Now first we should check with the corner condition, like if my root is equal to null, so that time we have to return, we can't proceed with the thing and we have to return immediately, and then we'll be declaring our data structure stack that we will be using, and it will be of type in integer or node. We should take better, like okay, node and stack is new stack, and yeah, will be just first element will push it first. Okay, so that our stack is not empty. For stack dot push the first element, that is root. Okay, now again we'll be starting off till my stack it's not empty. Okay, stack is not empty, till my stack it's not empty, it will continue and it will be moving, and it will store like will be popping out the element like a current. So node will be using like a current is st dot pop. Okay, and will be first element has been popped out, it was pushed and it has been popped out, and then we'll be checking if it has a right element. If it has a right element, then push it into the stack. Then we'll be checking for the left element, if it is present, then push it into the stack. So if my current dot write is not equal to null, so just push it st dot push, it will be current dot write, and if my current dot left it's not equal to null. Okay, then just push the current dot left part as well, and we'll be checking like if my stack still my stack is not empty. Like first we have checked like if my still the stack is not empty, still my stack is not empty, so So what we will be doing, like current element, we have pushed 2, 5 and 2, and we have to arrange it in linear form. So what we will do is like 1 dot right, we'll attach it to 2. Okay, we'll attach it to 2, like current dot right, whatever the current element is there, right, we'll attach it to the st dot peak, whatever the peak will be there, peak, it will be 2. Okay, so peak 2 will be there, so 2 will be attached to 1 first, since it's the left part, that's why we have put like a right first and then left, so that when we are popping out it, the left part will come first. Okay, so this was the reason, like I have push the element like right first and then left. Okay, and then we'll be putting like a current dot right. Okay, current dot right is equal to st dot peak. Okay, and one thing you should be carefully noting here is like we are not popping out the element, we just peak. Okay, so it will just return the topmost element, it will not remove from the stack. So still 2 is already present in the top of the stack, we are just connecting the one right part of it to 2. Okay, now now again we'll be proceeding with the next thing, and we'll be since 1, for 1 we have attached to the right part, but its left part is empty. Okay, so for the current dot left part will be putting null, and then again my loop will run over again, and it will be moved again, and current dot st dot pop, now the pop element will be 2, because we have pushed the last element as a 2 element. Okay, now it will be pushed out from the stack, and if it has a current dot right and left, it will be pushed into the stack. So 4 and 3 it is pushed, so 3 is at the top, one thing you should keep in mind. Okay, 3 is the top. Okay, now again here it will be current dot right, its stack is not empty. Okay, current dot right, that will be this current, that is 2 dot right, will be st dot peak, peak element is 3, so 1 2 and 3 will be attached in a row, but still 3 is present in the stack, so it will continue to remain in the stack, but just a connection has been made, like a 1 dot right is 2, 2 dot right is 3, and all of the left part is null. So again we'll be putting like a current dot left for 2 is also null, then again it will be moving to the popping out the 3 from the stack, it will pop out 3 from the stack, putting it in the current, and here it will be again current dot left is null. Okay, right is null. Okay, nothing will be over here, but here coming to this part is st dot is empty, it's not empty, so it will be current dot right. Okay, so current dot right, it will be 3 dot right, for 3 is right, it will be st dot peak, so the peak element will be 3 was 4 was pushed, 3 was pushed, so 3 has been popped out, so now it has 4 as a peak element, so 1 2 3 and 4 will be attached. So here you can see 1 2 3 4, 4 till we have done. Now again it will repeat the same for, and it will pop out 5 and then 6, and it will get attached in a similar way. And so we have done the dry run on this, so we should just check it if it's running for the test cases properly. So yeah, we can see it's running properly. Now for all other test cases we should just check it, but you can see it over here, like we are using an extra space. Okay, now it has run successfully, but one problem over here is like we are using like an extra space as a stack, so our space complexity will be order of n, and time complexity is order of n, because we are moving each of the element as a one time at least. So but we can more optimize the space in this, what we are using to optimize the space that we are using is like we'll be going for another approach. Now I'll be telling you the another approach of the same problem. Now what we are doing is like we'll not be using any extra space like stack. So and what we will be our approach to the problem will be like, if my root is not equal to null, we'll proceed with our problem like in while. Okay, and if my root left part, okay, root left part is not null, like it's not null. So what we will be doing is like we'll be keeping it in a temporary variable, and we'll check if it has a right part. And if it has a right part, like 2 has having a right part as 4, so we'll moving deep into this path, and whatever the rightmost part will be there, we'll just swap it, and we'll put the pointer and we'll change it. Okay, so previous whatever it will be, previous dot right, it will become like root dot right. Like from here, it will be pointing to the root dot right, like whatever it will be, like 4 will be pointing to 5. Like here you can see like 4, it will be pointing to the 5 elements. Okay, and root dot right, and root dot right, previous dot right, and root dot right will be root dot left. Okay, and we'll be moving for 2, for this 2, will be moving its right pointer to its left, and the root dot left will be pointing to the null. So this way we'll be arranging the things. Like we should go with the problem statement, like how we have to do. Like if my we'll be first checking if my root it's not equal to null, then only it will be proceeding. Okay, and then node will keep a previous element as a current previous element, and before that we should just check that if my root dot left is not equal to null. So if my root dot left it's not equal to null, so what we'll be doing is like we'll be moving with the previous node. So previous is equal to root dot left. Okay, and root dot left, we'll just keep it as a root dot left, and we'll be checking like if it has a another kind of right element, and then we'll go to till the depth of it. Okay, so um if my pre previous dot right, so previous dot right, it's not equal to null. If it's not equal to null, then we'll be moving to deepest whatever the previous will be there. So previous dot right. Okay, and then if when we will be finding the rightmost element, we'll just moving the pointer. So previous dot right is equal to root dot right. Okay, root dot right over here, like previous dot right, that is 4 right part is equal will be pointing to the root, that is 1 right part, so 4 will be pointing to 5. Okay, and then we'll be moving like previous, that will be 2. Okay, sorry, root dot right, like for root is 1, so root dot right part is already connected to 4, so we don't have any need of pointing 1 right to 5. So right will be pointing to 2, and right 1 left will be pointing to null. So here we'll be pointing like a root dot right is equal to root dot left, and root dot left will be pointing to null. So here we'll be completing this, and yeah, after completing this thing, like one thing we need to do over here is like the next element, like it should point like to the root dot right. Okay, so here it should be like a root dot right. Okay, and root dot right. Okay, so root dot root is equal to root dot right. Okay, now checking for all of the test cases. Okay, some error is there. Okay, okay. dot left, first of all, like root is not equal to null, and if my root dot left it's not equal to null, then root is equal to root dot left. Okay, if my root is not equal to null, then node of previous is equal to, okay, node previous, okay, root dot left, while previous dot right not equal to null, previous is equal to previous dot right, previous dot right. Okay, and here only I'll be declaring like a node, and we'll keep it as a block. Let's see if it's run. Okay, yeah, it's running. So what we did, like this whole, if the left is not equal to null, then only the whole process should continue. Okay, so this thing we need to take care of it now. That's a medium level problem in a GFG. It's a bit easy thing only. um, just you need to take care of the traversal, like which node to traverse first, and when the node need to be inserted, and how the link need to be changed. Okay, now practice this well. It's an important problem related to linked list, and it's most frequently asked in an interview as well, so prepare well. If you have any doubt, please put in the comment section and I'll try to reply. And till then, please do check out the other videos that has already been uploaded, and do hit the subscribe button and be updated with all the recently updated videos. Thank you.